Today we will discuss hybrid inheritance. The basic idea of hybrid inheritance, that whenever a class inherits another class, and in return we know that a class can be inherited multiple ways. One can be simple inheritance, that is this one, that you see this is a class A, and class A is being publicly inherited by class B. So this is one type of inheritance, simple inheritance. Then there can be multiple inheritance. Okay, there can be multi level inheritance. That means one class can be inherited by two class. Okay, another can be that two class are one class can be inherited by two class, or two class can be inherited by one class. So this is an example of that you see class D is inheriting class B and C. Okay, and another example can be, if I just make it a public, let's assume this one, you see class A is being inherited by class B and C. So that can be another example. So this is a simple example when one class, public class A, is getting inherited by public class B. So this is our normal inheritance. Then there can be another example that class D is inheriting from class B and class C. So this is another type of inheritance. Then one class can be inherited by multiple class, like for this one, see class A inheriting B and C. And finally there can be multi-label. So what does multi-label means? To show you the multi-label, let me take the help of the board. So let's assume we had class A. Now class A is got inherited by class B, which got inherited by class C. So this can be called a multi-level inheritance. We have talked about these different types of inheritance. It should be available in one of the previous lectures. If you forgot, you can have a look. Now another is hybrid inheritance. So how does it look? Let's assume we have a class A which is being inherited by B and C, and in return, okay, let's erase this one. So class A which is being inherited by class A and C, and both of this, there is a new class, let's assume the name of the class is E, which inheriting class B and C. So this is multi-level inheritance. At the same time, this is multiple inheritance, and so on. So in these cases we use the term hybrid inheritance. So let us see an example of how hybrid inheritance work. So in this problem definition, what we're doing, we start with class A. In the class A we don't have anything, we just written a public member, that is integer x. Then in the class B, which inherits public A, okay, it also don't have anything, it just adds a constructor. So in the public class A we only had a variable x, and in this one we all had a constructor which inherits uh, the public class A. That means the code you have here is being copied here as well, and it adds a constructor that initializes x to 10. After that, in the class C, okay, this is also a public class which have a variable integer y and a constructor that initializes y to 4. And then we have a public class D which inherits B and C. Okay, and what it does, it actually prints the sum. Okay, so what it does, it prints the sum of xy. So this is a member function which prints the sum of xy. And finally we have a um, in the main we have a object of class D, and the object calls the member function sum. So before going to let me show you what happens by running the program, then we'll explain step by step. So if I run the program, you'll see the output I get is 14. Okay, so how did I get 14? Okay, let me just change a bit. Okay, let's make it 11. So you see the output that I'm currently getting is 15. That means the value that I'm changing here is affecting the sum function. Okay, now obviously it will affect the sum function because we can see sum equals to x plus y. So we are changing the value of x or y, the value of sum will also change. Now that we understand that sum is changing because we are changing the value of x and y, but the question is, okay, how the actually the program is working. So let me explain step by step. First, whenever the program starts from here, okay, we create an object of D. So we know that whenever we are creating an object of a class, we write the class name, okay, class name, and gives a variable name or any object name. So many of you got confused in this part. We're discussing C++ for a long time, but I think some of you forgot. So this is the basic structure. Okay, we create a class name and we create object name. So same way, we have a class name that is D. You see from here, class D. So this is the class name, and the object name is object one. You can use any other names as well. You can name it A, you can name it Z, you can name it K. Any variable names are allowed. In our previous chapters, we have seen a concept with where you can use, there are three rules for declaring an object name. Now, as I was saying, so then what we do, we create the function sum. So whenever we create the functions, call the function member function sum, it goes to this program, class D, public B, and public C. So when it goes to this program, okay, we can see that in this one we have only a function that is sum. So where did it get x and y? So now we have to go back to this C class one by one. So we can see that whenever the class C, okay, what it does, it's in the class C we have a variable and it initializes y to 4. So that means this code will be copied, or we can say this code will be executed. So whenever the sum function is called, okay, what it does, it x plus y, it adds these two variables. So whenever we are trying to create x and y, okay, first this gets initialized, and also in the B this gets initialized. So this is, if I just forget about this one, public class A, if I just write it here like this, okay, I think it will make much more sense to you. Integer x, okay, so you see the program will not change. You see the result of sum is still 14. So what is the difference here? So what we're actually doing, we're dividing a simple step into multiple classes to show you that how the program actually works. Now to make you understand, I will use a printf in here. Okay, so in this one I will use a printf. Let's where do you have, yes, let's use a console output for this case. Whenever we come to the constructor, so we will just call hello, hello from B. Okay, so we'll call this, and whenever we go to this, we'll call hello from C. Let's see whether it works or not. Okay, and whenever we come here, we'll print, we know that this worked because we can see the sum. So let's run the program again and let's see what happens. Okay, I have to use ENDL. Mm, let's run the program now. So look closely, okay? So when you create an object, it's okay. Okay, nothing happens. Then when you call the member function sum goes here. Okay, so whenever sum starts executing, okay, it says that it has to sum up x plus y. Okay, so whenever it starts to sum up x plus y, okay, this x plus y are actually variables or member variables of class C and class B. So out of these two, first we have X and then we have Y. That means first we'll go for class B. So whenever it goes to class B, okay, it comes to the constructor, and in the constructor we have a printf hello from B. So first we get this hello from B. Then after initializing value of X equal to 10, it comes back to again here. Okay, and then it goes to Y. Now what Y does, it actually tells you that okay, go back to the this class C because Y is available in class C. So in this one, what it does, it actually prints this constructor hello from C and Y equals to 4. Finally we can see the sum. To test our program, what we can do, we can change the order. Okay, we can, instead of writing, we can write Y plus X, and let's see what happens. You see, it's still the b is getting called first. So that means changing this doesn't matter. Okay, which function we are calling first. Okay, let me then do other change. Okay, let's make it x plus x. In that case, the value of x should be doubled, but you'll see that if I run the program, it is still calling hello from b, hello from c. That means it doesn't matter whether what we do in this function. Okay, even if we don't call this function, let's forget about this one. Okay, let's not call this function. Even if we don't call this function, you will see still we're printing hello from b and hello from c. That means as soon as we create the object, we know that constructor is a function or a method, a special method that's get called whenever we create an object. Now what we have already told you about this, that whenever you create a object of a class, constructor gets called. We have talked about this, but the thing we didn't actually know, that what happens in case of hybrid inheritance, because we are inheriting this class, public class D, and in public class D we don't have any constructor. So should it call the constructor of the parent class? The answer is yes. We can see as soon as we create this object d object 1 and we run the program, okay, it automatically calls the constructor of class b and class c. So to answer in one line, in case of hybrid inheritance, even if the derived class doesn't have any constructor, whenever we create the constructor of whenever we create an object of the parent class, the constructor will be called. Let me write it down. So in hybrid inheritance, even if the derived class that we're creating object don't have any constructor, if you an object, okay, if you create an object, what it will do, it will call, okay, what's, just a second. Okay, so if you create an object, it calls the constructor of the parent class or classes. In our case, there are two classes. Okay, now let's go back to our here. So now we can see if I run the program, we have seen that it's first calling the constructor of the class B, right? Let's run the program again. Why it is calling the constructor of the class B first? Okay, we also have to know that. So you can, let's try it here. If I like change it to C and B, does it change? So we first we're inheriting B, now we are first inheriting C. And if we run the program, you see now it changes. That means what we write here, it actually matters. So as we have previously, we have written class B first, it was calling hello from B, and then it was calling hello from C. So now we have, what we did, we have changed the order of inheritance. So it actually is not that important because eventually both will be get called, right? So it's not that much important. But anyway, let's go back here. So now we know that it matters that which one you write first, okay, in terms of constructor calling. But for a normal overall task is same, okay, it doesn't matter that much. Now secondly is that this one we understand, I hope you understand that we have created a class C which have a public member Y, and then it also, what it does, it actually calls the it's a prints hello from C. Just a second. And in this one, what we did, we could have written same as C. Okay, we could have written that integer, we can read public variable here, and it will still be the same. But what we have tried to show, okay, that sometimes, okay, we can divide in these two classes as well. Class A only provides this variable and class B provides the constructor. This is one superclass and one derived class. Combining these two, we have this class of class public B. So this also gets work in the same way. So this is our first example for hybrid inheritance.